Hi, thanks Arise Observe for organizing this conference and for hosting our talk. My colleague Yuanbo and I are going to talk to you today about optimizing through automation, end-to-end data quality assurance, and model deployment. And we're both currently at Spectrum Labs, where myself, Nina Lopatina, I'm the Director of Data Science.
And hi, my name is Yuanbo. I am a principal machine learning engineer.
And so to set the stage a little bit about what our model and data needs are, we're an NLP startup that focuses on text classification, which is divided between content moderation around harmful behaviors, as well as detecting healthy behaviors to help platforms encourage positive engagement. So with this significant number of behaviors that we cover, as we've scaled up the number of behaviors we've supported and continue to add behaviors, we needed to automate the pipeline to retrain models as we incorporate more data, as Yuanbo will go into more detail on later. And in addition, as these are user-generated content, language changes over time, so we need to continually retrain our models so that we're keeping up to speed with current slang and other terminology. And we cover about 21 languages as we operate over the world. So with over 20 models, we need a scalable process to do quality assurance on our labeling operations with more languages than we have expertise in-house.
Yes, and as the company grows, we're seeing the need to expand our ML products, and we're also serving more and more clients. From an operations perspective, it naturally becomes very important to look at the whole system that supports the ML lifecycle. In other words, we are really looking for switching mode of operation. So instead of working with a proof of concept type of mentality, we need to optimize for a seamless task production. So generally speaking, we can break down ML life cycles into three parts: data preparation, development, and operations. So in data preparation, we're looking at everything about data. For example, collection, quality assurance, building up the feature store, setting up the configuration to manage data flow. In development process, this is very well researched area. We have tons of algorithms that are available out there. We have experiment management tools and platforms, and we have best practices around model training and validation. On the operations side, we have everything related to model serving and building a product, including platform resource management, model deployment, monitoring, serving infrastructure. So those are the big areas. And in this talk, we're going to share some experiences on things that we have done to close the gaps between those different steps. And we'll primarily focus on data quality assurance, model development, deployment, and monitoring.
Thanks, Yuanbo. So I'm going to dive a little deeper into what we're specifically talking about for data quality assurance. So to set the stage a little bit on how much data we're working with, we have billions of labeled data interactions, meaning that for each labeled data point, we are sourcing the data, we are labeling the data, we're reviewing the labels, and then we're training and retraining our models, both language detection and our primary behavior models many, many times. And then we're working with hundreds of billions of consumer messages that we're applying our models to. And so we have to spend a lot of time curating the data, and we have a process that has several steps. So we define our labels, we vet our labelers, we sample the data, and then after labeling the data, we review the data. But as we are scaling up our data vault and model retraining workflows, we need to scale our data quality assurance operations as well. So we have kind of a workflow here of how several teams within Spectrum Labs operate together in order to get the data into the models and out to customers. And I'm going to focus on the left here on the sections in green. So after data prep, the data is labeled and reviewed, and then it's ingested. And what we're adding is a automated quality assurance step coming from the data science team that involves a depth score, which is a score calculated by a vendor that we work with, Galileo. And that score will flag individual rows of data that are likely to have unexpected labels. And then we're also calculating Cohen's kappa, which is a measure of inter-annotator agreement. So this is calculated for a language behavior pair to highlight annotator disagreement. So we're still going to have a manual review step, but this process helps prioritize data that is likely to have quality concerns. So diving a little bit deeper into Cohen's kappa, the example here is a few rows of text in both English and Russian. And you can see these blue columns, label 1 and label 2. Those are the inputs that Cohen's kappa is operating over. And in our labeling process, if we do have disagreement, we have a third labeler reconcile the disagreement so that we only have one label at the end. So, so for Cohen's kappa, it's the probability of agreement minus the probability of random agreement divided by 1 minus the probability of random agreement. So the Cohen's kappa for the English examples here is 1, meaning perfect agreement. And for Russian, it's 0, indicating that there's no agreement beyond that which you would have by chance. So in this QA step, we'd be flagging just the entire section of Russian data that we had labeled in this case as an example for hate speech. And so this would flag language behavior pairs that need to be reviewed, relabeled, or discarded. And we like to do this on a language behavior level because there could be quality concerns between different language speaking labelers, as well as confusion around the lexicon, or there could be cultural differences. Any number of things that could be contributing to labels that could be unexpected. And the Galileo depth score, this is a metric that operates based on a hybrid AUM mechanism to identify examples that might be contributing to lower model performance, and it's also useful for identifying unexpected labels. So in this case, we have our final label that we had determined from the labelers, and then we've trained a model, one of our models that we would use to detect hate speech, and then generated a prediction based on these inputs. And then Galileo calculates this depth score, and a higher depth score indicates a likely mislabeled sample. So for example, and these are all just approximated just for the sake of easy examples. So for example, there was an example here in English that was hateful content that was mislabeled. The labelers agreed, but this would help flag that this is an example that we would want to review. And so even though this is a little bit more precise in identifying rows, it's also subjective. So it could miss examples because it's based on model output. So we like to combine the more objective Cohen's kappa along with this more precise, but potentially more faulty method. And then after these two approaches, then the data can be reviewed in a more streamlined fashion.
Okay. Yes. And then once we have assured our data has good quality, of course, there are many other steps that has to go into in order for the data to be available in feature store. But what I'm going to be talking on for the next section is jumping to the deployment part to see tasks that we are doing or we have done to make this whole process more automated. So taking a step back, in the ideal world, once we have the data prepped and vetted, we want to directly use them in the ML model development process, which will be streamlined into operation and directly used by our clients, and we can monitor them. And then the operation side can give immediate feedback to the model development part so that we know if there are things that we need to tweak for the models. And then if the model cannot be sufficient for the operations feedback, then it further feedback into our data preparation process to either sample more data for labeling or do some resampling strategy to retrain. So this is an ideal way. And then the time to production should be a streamline. However, in the reality, we are seeing many practical challenges. One thing that's very common is the path to production is very zigzag, and there's a lot of glue code involved around stitching parts together. And then when the model is in development, the feedback loop from operation to development is also quite manual. And sometimes it also takes even an incident to happen in order for the researchers to realize that something is not working. So when we think about what we need to do to break down the problems, here are some high-level questions that we have to ask ourselves. In terms of ML trade-offs, so that's a very big point. We, from the research perspective, we're always trying to optimize for performance, meaning mostly quality. There are some offline metrics that we monitor, for example, F1 score, accuracy, PRAUC, etc. But most of the time, we are not living in a vacuum where the offline performance is the only metric. So we also have to take into account speed. At Spectrum, we one of the things that we are very proud of is that we can plug in our complicated ML models into a real-time prediction API, which has less than 100 milliseconds of latency. So in order to achieve that, we really have to make a trade-off decision between our speed and quality in terms of the model performance. And then that introduce further trade-off decisions that we make when we want to improve our model architecture. For example, how do we fit a large model into that short of latency while we're increasing the number of parameters in the model while the model itself has a longer prediction latency. So those are the major trade-off decisions that we have to constantly make. And then in addition, we also have to think about monitoring. How do we proactively identify any future problems and can pick up those future problems? And the last thing around trade-off, last but not least, is how do we allow flexibility in this process? For example, if we want to give customization ability to the clients, what kind of interface can we provide in order to integrate our ML model into the whole production system? Moving on to the next, we also are building ML applications. So previous slide. We're also building ML applications rather than just the ML model. So there are certain business KPIs that we have to take. So, for example, like when the biggest question we're asking is, does our offline metric directly relate to the business KPI? And how do we measure that? And then in addition, there's also scalability around data. Transaction happens, data coming. How do we develop a robust data management workflow to keep everything at the same place? And then in addition, the automated testing should be very important because we want to integrate the CI/CD philosophy in software development and having detailed and automated testing around our ML models and products. And then besides those 2 points, the observability and is also very important. So we need to have very early on quality checks around data. That's exactly what Nina just mentioned. And then we also have to continuously measure the model performance and relay that to our business KPI. In addition, in the production setting, how are we doing in our system resource perspective? Are we using a lot of CPU? Do we need more computing power? Is our server working healthy? So those are all important questions. In addition, another question that we're constantly asking ourselves is what to build and what to buy. For example, the serving and deployment part is always very often in-house. And then, but for other stuff that we want to use, can we outsource them into a vendor? For example, Galileo can provide something that's very easy to use. And then weights and biases are also good for providing registry, etc. One thing that's very important to consider when we're deciding build versus buy is around data privacy, of course. We definitely don't want to share our own data unnecessarily or without any prior notice to the vendor, or more importantly, we definitely don't want to share our customers' data with external vendors. So going a little bit more into details, when we're building our automated ML deployment workflow, there are things that we consider. So first of all, we want to define what is the deployable target. So in our case, a deployable target is a trained and tested model artifact that can be directly integrated into the inference pipeline in production. And then so that involves 3 major steps. When we're packaging the tools, we want to think about what to package and can we standardize a tool for both offline and online purpose. That includes things like processing and model registry and the GPU and CPU, the resources that we're using for training. How do we manage that? And then for the testing part, we want to make sure that we're monitoring if there's any distribution shift in our training data and the features fill rate, are there a lot of empty values, etc. And if we're using a new model architecture, are we using the right loss function? Are we getting the right expected dimension at different stages? So that comes to the ML functional testing. And last but not least, there's also feasibility testing, which comes back to how can we actually fit a model into our 50 milliseconds latency? Is that feasible? Can we see a cost reduction for this model? And then in addition to all those above, we have to integrate the model into our whole system. We have to string together different modules. We have to track experiment. If there's any online experiment, to the offline candidates, which one is the best to go into production, and what do we monitor, and how is that related to the business KPI? That is a lot to cover, but we're also working on some monitoring or model management efforts. So, for example, once we have the model updated in the serving environment, how can we what motivates us to retrain the model, and how do we know if the model is still doing well? So do we want to set up an automated model retraining mechanism whenever there's new data available in the feature store? We just pick up the workflow immediately. And then, of course, we want to manage the resource around serving. And in addition to that, we want to look at, again, the model drifting, the performance on the business KPI, and to always be in the loop for potential problems that is going to happen. So that's a lot that we have covered today. In summary, again, this is like taking a step back to look at the whole ML lifecycle. We touched upon the data quality assurance part in the data preparation part, and then we're also sharing some thoughts behind how to do a model deployment and monitoring in our example. So yes, that's pretty much all we have to share today. And I'm gonna continue.
Yeah, thanks for joining our talk. Thanks, Arise, for organizing this. And you can contact us at this QR code, which goes to a contact site on the Spectrum site. Or if you have any questions for us, please drop them into the community chat.